Okay, I will share my screen. You are able to see my screen, right? Hello?
Am I audible, sir?
Yeah, you are audible. So you are able to see my screen,
Yes, sir.
right?
Yes, sir. Yes.
Okay, good. So we'll wait 1 or 2 minutes so that others can join. And if not, then we can start within 2 minutes, okay?
For sure, sir.
Yeah. Okay. Okay, so let's start. It seems that no one will join. Okay. So welcome everyone. Uh, Welcome to the problem solving session. This is the problem solving session for this NPTEL course named Basic Thermodynamics, Classical and Statistical Approaches. And the instructor of the course is Professor Arnab Mukherjee, who is from IIT Pune. This is the assignment solving session of week 9. And I am Dibyendu, as you all probably know, since this is the 9th week of this problem solving session. And I'm a Prime Minister Research Fellow at IIT Kanpur, and I in the Department of Physics. And so this is my website where you can follow the research topics that I'm working on currently, and all those live sessions of this problem solving session is being uploaded here in this YouTube channel, and you can find these tutorial sessions in a playlist by the name of this course, and you can check them out if you haven't checked them till now. And if you like the content, and if you like the things that we have been discussing here, please leave likes and comments there. Okay, so before moving on to this today's problem solving session, there were a few confusion regarding two problems basically, and Mugilan was right to point those out, that if in those two cases particles and energy levels both are indistinguishable, why we are treating those two problems differently. And I thought about those things, and I try to solve it, and I think what Mugilan was trying to say was correct. So let's try to revisit the thing. So first problem that was thing, this 9 particles to be okay. So 9 particles are to be distributed among 5 energy levels, and both the particles and energy levels are indistinguishable. In how many ways can this be done? Okay, and the consequent problem was determine the number of ways in which 5 indistinguishable particles can be put in 7 indistinguishable boxes. So Mugilan, you don't have any problem with this last problem, right? This problem, right? Problem was on the previous problems, like the 9 particles in 5 energy states, right? Because we were treating that differently. Hello.
Sir,
You are not audible, Mugilan.
am I audible, sir?
Yeah, now you are audible.
We got
Your voice is breaking.
Sir, in that the previous problem only we got that confusion
Yes, that
while
is.
dealing with it.
Yes. Okay, so now that I was just mentioning that the way we did solve the problem the previous day is incorrect. So what we actually did, we tried to do it by this way, right? This is ni plus g minus 1 factorial divided by ni factorial g minus 1 factorial. This is incorrect. It is incorrect in this sense because when you are trying to separate out those things, means there are n particles and we are trying to do these things, there the way we are doing, we are over counting in this way, because let's say here this is 3 and we just put the partition here, there will be this 3 and 2, so in that way the distribution shouldn't change, right? But we are counting that also as one state, as one microstate. So that is one mistake that we are doing, and it is because there the energy levels, because we were employing Bose statistics, but in that energy levels when we are trying to do that thing, and here these energy levels are quite not similar, because they are, when you are trying to do these two partitions, we were over counting, but if it is indistinguishable indeed, then that shouldn't happen. So the correct way to do this problem is, there are 5 energy level, let's draw them out. And if you think like these are 5 energy levels, one assumption we can make that each energy level must be filled, okay, because we are distributing it, and we are, because there can be one, let's assume that each and every energy level must be filled at least by one particle. So you will put one particle there, now you are left with four particles. Now these 4 particles can be arranged as 4 0, 3 1, 2 2, 1 1 and 1 1 1 1 1. Any other way possible? Mugilan? Hello, am I audible?
Yes, sir, you're audible, sir. I said no.
Okay, so if that is the case, then how many possibility is there? This is 5 only. So that would be the case, and which turns out is probability of grouping 4 particles in different way. And you have asked me, is there any other way to calculate this thing by any formula? It is possible, but there is no closed form. So the formula is, if you try to group n objects and which are in integer in k groups, then Pnk has some form. This is called partition function, not the partition function in statistical mechanics, partition function in number theory. Now this I just want to give you some context here. This actually discovered and actually simplified by our own Ramanujan sir. So in his, when he was very ill, he came up with this partition function, some kind of asymptotic form, and it is very difficult to write in a closed form. But I can give you some number, and there are some Euler generating function and Young's form, this kind of counting thing, but these things are beyond the scope of this course. I can give you some number, then you can this thing. So P of 0 means 0 particles can be grouped is one way. 1 particle or 1 can be grouped only one way. 2 can be grouped 2 ways. 3 can be grouped how many ways? 3 ways. 4 can be grouped. 4 can be grouped. Four ways. Here
4 ways.
Here 40 is not counted. Okay. 5 7 ways. 6 11 ways, like this way. Okay. So this is the thing. Now for our problem, if the assumption is we have to at least fill all the energy levels by one particle, then this is the answer. And if not, then the answer would be P9, means we have to, how can we distribute 9, and which is a very big number, we have to do it by this way. Then P9 will be, P9 is 30. Okay. So that is the thing. But here, seeing the option, I think that is the questioner wanted to know. But in this kind of problems, it is always tricky to, I will say that this here the information is incomplete. So you have to be given more information to come up with answers. But seeing there are 4-5 answers, so we have to give the closest answer, and we have to take into account all the possibilities, and after doing so we can see that it will be 5. Okay.
Okay, sir.
Okay. So this is wrong, this is right. Okay. And here, what was the answer last time? number of 5 indistinguishable particles can be in 7 distinguishable boxes. So P5 is 7, right? So by saying, what will you this answer? P5
Yes.
7, right?
Yes, sir.
So that is the thing. So you will try to remember for P10 up to P10. I will give you the P10, and after that these things follows, because in the exams there will not be that difficulties. And also probably in your course you are given some identities, right? That P and K means, that means I will come into this thing is n minus 1 k minus 1 plus what is that? What is the other thing? Do you remember?
No, sir.
N minus k. Now it is written, how to interpret it? Interpret is how can we group n object in k groups. Okay, this is the thing. So this identity tells that we can, the way we can group n objects in k groups is equal to grouping n minus 1 object in k minus 1 group plus n minus k object in k groups. Okay, this is the identity. It is quite mathematical and number theory thing, and this beyond the course of scope of the object. Okay,
Okay, sir.
it is clear now. So there will be no problem, right?
Yes, sir.
Yeah. Okay, so let's come to this today's problem solving thing. So the first problem for this thing says, distribute 6 units of energy among 5 indistinguishable particles such that each energy level can occupy 0, 1 or 2 particles. How many distributions are possible? Can you do this, Mugilan?
Yes, sir. I will try.
Yeah, we'll try. Take 1 minute. You can do this, Mugilan. It is easy.
I'm sorry, sir.
I'm saying that you can do it. It is easy. You can do it.
It looks like we have to um, the six energies should be supplied in five indistinguishable particles such that you have zero in one and
Yes.
one in another.
So your voice is breaking.
And one again. So it's raining here, sir, I think.
Okay. It's raining. So you're from Tamil Nadu?
Yes, sir.
Okay, good. This is the time to in Tamil Nadu. They are like two times this to rain, right?
Yes, sir.
Okay, I will help you. Okay, just
Yes, sir.
yeah. Okay. Now we will do the same thing. Okay. So 6 unit of energy. How can we break them up? 60514233. Rest of the zero. Rest are zero. 33 3 2 1 2 2 2. This is not possible, right? So 0 1 or 2 particles are in can be there. This is also not possible because 2 there will be 3 particles at 0. This is also not possible. There will be more than 2 particles at 0 energy level. This is also not possible. This is also not possible. This is possible. This is possible. Now if I write, this is also not possible. This is possible. This is also possible. Okay, and 2 2 1 1 is also possible. There will be no other things. You cannot write in other way. So one way to do this is just write the energy level 0 1 2 3 4 5 6. So from let's start from 0. So if there are can be 2, first fill 0 0, and let's fill 1 also. 2 is there, so one particle is left that needs to be at 4. Let's make here 1 is here, 1 has to be here, 1 is to be here. That is one thing. Any other way cannot be possible keeping 2 particles at 0. So we have to make less particle kept at 0. So let's 1 less, then 1 particle can be here, so let's keep it here. Now 1 unit of energy is increased, so this particle means less. So now we have just put 1 particle above, so the total energy for this 3 and this 3 is for this 3 it is being increased by 1 unit. So for this particle needs to be here, so that there will be total number of energy 6 unit. So let's do that. No other way is possible because here we have another extra constraint that each energy level cannot occupy more than 2 So there will be only 3, right? So this is 3. Okay, clear?
Sir, actually, I don't understand that.
Yeah, don't understand?
But, why the first one and second one are little bit of different?
First
I'm sorry,
one,
first and third one. And third one
uh,
means they are just like opposite of each other. One is upward and one is downward. Then
yeah, but here the energy levels are different, right? Here 410, here is 2211.
so then there will be some other configurations like there will be 4 and 0 and 1 collectively, and we'll have only one in the sixth or fifth one, then third one, then second one. Like that, we'll be just moving on having a single particle in every level, right, sir?
No, what you are trying to say? Now let just one by one. Let's go one by one. So this and this is different. That is clear, right? So here if we write the energy levels for this thing, let's write this thing. This is 4 1 1 0 0. For this 2 2 1 1 0. Now these two are different. Okay. Now your point. Now you say your point. So these two are different. That is true, right?
Sir, 4 1. I still cannot understand that how they are mapped actually. Like 4 1 1 0 0.
4 1 1 0 0 means here 4 unit of energy in here one particle.
Okay.
Yes.
Okay.
Here one
Now I
particle.
understand.
Yes. Here one particle is at that energy level, that energy state where there is 4 unit of energy. Okay.
Okay, so now I understood, sir.
Okay.
Actually, I was going the other way around. I was
Okay.
mapping particles with energy levels.
Okay. 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 Yeah. Now I
Okay, sir.
understand. Yeah. Okay. Great. Okay. Let's move into the next problem. So next problem, it's quite simple if you think like that. Consider a system containing Avogadro's number of ideal gas particles. In state 1, the volume of the system is V1 and it is divided into N1 cells, means N1 possibilities of volume V. In state 2, the system volume is V2 and it is divided into N2 cells of volume V. Now we know that V2 is greater than V1. Now using Boltzmann formula of entropy, which is S equals to Kb ln W, write an expression for the change in entropy delta S when the system goes from state 1 to state 2. Can you do it? Try it. I will give you 1 minute, and whatever you tried, just try to communicate with me and I will then solve it. Okay?
Okay, sir.
Okay. Yeah, Mugilan.
Sir, I'm not sure about it, but is it the option B, delta S equals to R ln V2 by V1?
Yeah, absolutely, absolutely. Just tell me the thought about your solution.
Sir, actually, it may be correct or not, but talking about ideal gases, so gas constant should be used. And
Yes.
I think V2 by V1 will be a positive ln as V2
Yeah.
is greater than V1.
Yeah.
So it will give the delta S. So in that way only I
Okay.
thought.
Okay. Okay. Yeah. 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 Because if you follow our previous lectures, there was one problem also. So there was also like the delta S, the entropy change was R ln V2 by V1 also. But here we will do it in different way, because here we will do it in microstates, counting microstates, and that way. So just follow me. But your argument is right. Okay.
Okay, sir.
Okay. So now V1 is N1 V. V2 is N2 V. Now V2 by V1 is N2 by N1. Here N2 means volume. In volume space, the microstates took some volume, right? That is V. So there are N2 number of microstates, and it means N2 number of possibilities. Here N1 number of possibilities. Since there are any number of molecules, sorry, ideal gas, and for state 1, it is just like a coin tossing probability or dice probability. Just think about it like a dice which has N1 faces, and that dice has been rolled and are being rolled Na times, since there are any number of ideal gas molecules. So the microstate W1 will be N1 times Na. So similarly for state 2, what will be that? Mugilan, for state 2 or similar?
W2 equals to N2 by N. N2
Exactly,
NA.
Na, perfectly. Now we know that S1 kb ln W, so kb ln N1 by Na. S2 is kb ln N2 by Na, and delta S is S2 minus S1, and if you do that, that will be S ln kb Na ln N2 by N1, which is R ln V2 by V1. Okay, so this is the thing. Since it is being, there are N1 cells, so that N1 cells will be distributed in such a way that total number of distribution will be N1 times Na, N1 to the power Na. And if you do that calculation, it comes like this. Okay, but if you try to do it in using ideal gas equations and using thermodynamics, that also led to delta S is equal to R ln V2 by V1, and which we have done previously using that equation, and delta S means delta Q is equal to delta U minus delta W, and by doing that we have also got the same result, R ln V2 by V1. Okay, so, and that actually, yeah, Mugilan, you are saying something?
No, sir, I just said I understood.
Yeah. So from here, can we say, Mugilan, that statistical mechanics and thermodynamics are the same thing, but statistical mechanics is more from fundamental point of view, because here we are trying to see the system microscopically, right?
Yes, sir.
Yes. Okay, so we will jump into the next problem. This is quite easy. This is like theory. This is theory. So the problem says, we know that partition function formula is z, which is normally denoted by z, equals to summation over gi e to the power minus ei by kbt. Now for this, which of the following statements, it can be more than one also, is or are false about partition function? First option says it indicates the mode of distribution of particles in different energy states. Is it true? Or it is false? Or it is a dimensionless quantity. Third option is it can be zero. Fourth option is it applies to system of any physical state. Which option is incorrect?
I think it can be zero because recently only you said that P partition function of like n comma k will be like zero, or P of zero will be like 1.
Yes.
So it cannot be zero.
Yes, precisely. So, as just Mugilan rightly said, the first point, so this is the correct answer, but let's go deeper into this thing. So it obviously indicates the mode of distribution, because probability of an energy EI is proportional to e to the power minus EI kBT, or there will be some degeneracy GI. Now if you take the summation PI, then there will be summation over GI e to the power minus EI by kBT. Okay, so this is actually talks about, so if you get this thing and there will be some z by z, if you try to remove this proportionality constant, so there will be gi e to the power minus ei by kBT. So by z, so this z cannot be zero because it will blow up, but probability cannot blow up, and it is dimensional quantity that is prevalent from, that is actually visible from this, and it applies to the system of any physical state. That is true. So this is the only option that can be right, means this is the only statement which is false. Okay, it will actually, let's not write this, or it will actually, people will take it mistakenly. Okay, now problem number 5 says, in carbon monoxide, the spacing between excited rotational states is 0.025 kilojoule per mole. If the degeneracy of the first excited state is 3, calculate the fraction of molecules in the first excited state at temperature 298 Kelvin. Mugilan, can you do this, or I will give you some hint and then you will try?
Please give some hints, sir.
Okay. So Now, fraction of molecules, this is actually okay, let me go to this. So as we have just write, PEI is proportional to e to the power minus EI. Let's write it in this way, because I always write it in this way, e to the power minus beta EI, because we don't have to write by kBt, and why beta is 1 over kBt, and if there is degeneracy, then there will be degeneracy Gi. And and now if we get the and it says, so P excited E and P E ground is Gi e to the power minus beta E excited, means first excited state, divided by, in ground state there is nothing is given, no degeneracy is set, so I will keep it like this, is 0. And if you do that, that will give you Gi e to the power minus beta EF minus E0. And it is given, this is the energy rotational states, the excited rotational state spacing. So this is Gi e to the power minus beta EF minus A is 0.025 kilojoule per mole. Now to this. So Gi is known, this is known, beta known. Please, if you calculate this, that will give you the fraction of molecules. So please do that. Okay.
Okay, sir.
One tricky thing is, you have to, this is in kilojoule per mole, so you have to do it per particle. So you have to do it, the mole needs to be converted into particle, means Avogadro number will be there. So just do this. And tell me the answer.
Sir, is the answer 3?
It is not 3, it is less than 3, 2.98 something, right?
Yes, sir. But in options, I can see only 3.
So we can write it like 3, but that's the thing. So the same thing, you are right. So let me just complete it for your friends. gi is 3 exponential minus, this will be, let's write it in this way, exponential of minus 0.025, since there is mole, so there will be 10 to the power 3 for kg divided by 6.022, 10 to the power 23. Now for beta, that is 1 by kb, kb is 1.38, 10 to the power minus 23 times 298, and if you do that, let me put here 6.022 times 1.38 times 298, it's giving you 2.9698. So close answer is this. Okay, it's pretty simple. Okay.
Yes, sir.
Okay, this is also very simple. So these problems are very simple. Problem says consider the probability distribution function is given, okay, px, which is a x to the power n, for a positive integer n and a is a constant. Calculate the average value of x. So I'll again give you one hint. So average value of x is given as px x dx. Now can you do this, Mugilan, for me?
Yeah.
Okay, please do it. Just a minute, I'm coming. Hello.
Yes, sir.
Option? Which option? Option A.
No, sir. I'm getting something else.
Which option? None of the above you are trying to say.
No.
Okay, just let's do it. Okay.
Yes, sir.
Okay. Okay.
Yes, sir.
So just I will give you two things that will it will be useful for you in the rest of your life. So whenever a distribution is given, a probability distribution is given, we always have one thing, that this distribution, the integration of distribution is 1, because the total probability is 1. So the distribution, anywhere the probability is distributed between different spaces, that will add to 1, right? That is true. So one thing is there, and now here the range is 0 to 1. So this is always there. Now if we do that, then 0 to 1 a x to the power n dx equal to 1, that will make a by n plus 1 x to the power n plus 1 0 to 1 equal to 1, and that will make then a by n plus 1 equal to 1, which makes a equal to n plus 1. So this is one thing. Mugilan, do you agree with me? Whenever there is some distribution, now the integration of the distribution is the probability, right?
Yes, sir.
Then total probability is 1, and from that we can get this coefficient. Now we have to get the average, that is this. Now to do that, it will be a x to the power n plus 1 dx, that will give a x to the power n plus 2 by n plus 2 0 to 1, that will give you a by n plus 2. Now using this we can write, this is the correct option. Right? Do you agree with me, Mugilan?
Yes, sir.
Now it is correct, right? So the right option will be n plus 2. So first of all, this kind of problem comes is that we need to first calculate this coefficient, and this coefficient is always derived from this total probability. And whenever we got this coefficient, then we will distribute, then we will integrate for different moments, and this called like mean, variance, these are called moments. Now if we have to calculate x cube, we can do this. We will just integrate it, and we know the coefficient. We'll substitute the value of the coefficient, and we will integrate we will do the integration, and we will get the mode average mode value. Okay, so that's the thing. Okay, now seventh problem says, which of these two distributions shown in the figure below has the greater entropy? Now this I have actually done in the previous session. I will see what you have remembered. Mugilan, please.
Sir, option B.
Why so?
If I went through Boltzmann's distribution law, like S equals to KB ln W, so in the first equation I have ln 1, so ln 1 is actually 0, so I'll have S equals to 0. But where if I went for B options, I will have ln 5, which will give me some value that will not be equal to 0, so I will have the most number of most value of entropy.
Yes. So you are right. You have just said that entropy is defined as KB ln W, or minus, let's say KB here, KB minus Pi ln Pi, summation over I, means probability for each event. Pi stands for probability for each event. So there are 5 events. For first case, for A, there is P1 is 1 and rest are 0. That give me 0. And for B, S is KB minus 1 by 5 ln 1 by 5. Now this is for 5, so times 5. And if you do that, it will become KB ln 5. And ln 5 is 1.60609. So 1.609 KB. Now from this is okay. Now if you have to remember it physically, always remember most probable distribution, most entropic distribution is when all events are equally probable. Okay. Mukhilan, do you understand this statement?
Yes, sir, completely.
Okay. Now then answer me. Which coin has more entropy? Biased coin or unbiased coin?
I'm not sure about that biased and unbiased thing. It's a long thing. I do not remember it right now. But the thing which will have half and half probability of getting a head or a tail will have the more entropy.
Yeah. So biased means this half and half thing is not valid. One thing will be more.
Okay.
One probability of occurring one is more than others, and unbiased is, as you have just said, that equally probable. Okay.
Okay, sir. Thank you.
Yeah.
Thank you, sir.
Okay. Now extending to this thing. Now here there is a mistake in this figure. Can you say what is a mistake, Mukhilan?
Sir, I think there are entries missing, or yes, sir, the entries are I think missing, and you also have like the same half is a smaller one, and the same half is a larger one also.
Yeah.
So there is some.
So that is the thing. So it is written here as half, and if you add the probability there, it will be greater than 1. That is not possible, right? So here it will be all are equal. It will be 1 by 6. Okay.
Okay.
Now do this problem for me. Now calculate the entropy. Like here I have done this. Like here I have done this calculation. So calculate for these two distribution and tell me which will be the correct option.
So I'm not just calculating, but it seems that option C is going to be correct, because we are going to add the things only, like minus ln 1 by 6 minus ln into 1 by 6, like that we're going to add them. So there will be no change in having the answer unequal.
So why not?
So that
Then why not option A?
Oh yes, I didn't saw that. I'm sorry. Okay, sir, I'll calculate.
Yeah, calculate it. Hi Sachin.
Hello, sir.
So we are just solving this problem. So this problem is we have to calculate the entropy, and the entropy formula is given by this thing, means kb minus pi ln pi, where pi is probability for each occurrence. So by using, we need to calculate the entropy for these two processes that we are trying to do. Okay.
Sir, option A is correct, sir.
Yeah, fantastic. Thank you, Mugilan.
Thank you, sir.
Yeah. So as just Sachin, just follow me. Okay. So the formula is entropy is kb, which is Boltzmann constant, minus pi ln pi, where pi is probability for each, here each is occurrence or each event. Now for the first thing, so since for A and B, like there are 3 1/6 probability and 1/2 probability, so they will have same entropy, of course. Now to calculate that S, we need to do this in this way, skb. So there is 3 1/6 kind of thing, 1/6 probability, so that will be 1/6, 1/6, and 1 is half, so half ln half. And if you do this, then it becomes kb half ln 6 plus half ln 2, and that actually eventually gives you 1424 kb. Okay, so this is the correct option. Okay, Sachin, is it understandable? Understandable? Did you get it? Hello.
Yes, sir.
Okay. 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 So we will take 5 or 6 minutes break. Okay. Then we'll just come back. Till then, you can solve this problem. I can give you this problem. Till then, you can solve this problem. I will just read this problem out, and we can try. We can actually better use it in a good way. So the problem says you pay a slot machine in Las Vegas. For every $1 coin you insert, there are three outcomes. First outcome, you lose that $1. Option 2 says you win $1. That means your out profit is just zero. When you have given $1, you just got back $1. So that is profit zero. Option 3 says you win $5. So your profit is $4. Suppose you find that your average expected profit over many trials is $0. And the other thing is comment. Find the maximum entropy distribution for the probabilities P1, P2, P3 of observing each of these three outcomes. Okay. So is it visible, or I will zoom this thing? Mugilan, is it visible?
Visible.
Visible, sir, right? So just try it, then I will solve it. So you can use this break, or you can take your break and then we can join. Means we will solve this problem. Okay. Okay.
Okay, sir.
Yeah. Are you able to solve it?
Sir, I feel that option 1 is correct.
Option 1 is correct. Okay. Okay, let's check. Okay.
I haven't calculated.
Okay.
Yes, sir.
Okay, let's check. Okay. So here we have three unknowns, three variables, that is P1, P2, P3. Now there are only three events, so one equation we can always write, right? P1 plus P2 plus P3 is 1. Total probability 1 is always right? That is equation number 1. Another one is the average, that is P1 is the probability of the first event, that is you lose $1, that is -1, then P1 times -1 plus P2 times profit 0 plus P3 times profit 4. And what is the average profit? That is 0. So now if you write, that will be minus P1 plus 4P3 equal to 0. That is equation number 2. So we get P1 is equal to 4P3. Now if you substitute this here, then we get 4P3 plus P2 plus,
लेकिन व्हाइट बोर्ड सिर्फ वही विजिबल हो रहा है, क्वेश्चन नंबर 1 हो रही है, बाकी का कुछ विजिबल नहीं हो रहा है.
हेलो,
यस सर. सर इसमें सिर्फ आपने जो क्वेश्चन नंबर 1 की है उसके बाद कुछ डिस्प्ले हो नहीं रहा है.
हो नहीं रहा है?
नहीं
मुगिलान,
नहीं, मुझे तो सिर्फ क्वेश्चन नंबर 1 ही डिस्प्ले हो रही है, उसके बाद का कुछ आगे को वो ही नहीं हो रहा है.
It's visible for me, sir.
Okay, so there will, I think it is for like the network thing. You can join, you just disconnect and you join later. But join, just join promptly. Okay, Sachin, I'm waiting for you. Just disconnect and join again. Okay, just wait for Sachin.
Yes, sir.
I think he has some network issue. That's why he couldn't visit. Yes. Now you can see it, right? Sachin? Hello?
Yes sir.
Yeah. So this is 1. Now you can see it. Now if you write it, then 5P3 equal to 1 minus P2. Then P3 is 1 minus P2 by 5. Then P1 will be 4.
सर स्क्रीन शेयर नहीं हो रही है या फिर व्हाइट बोर्ड वो भी सब कुछ नहीं हो रहा है.
But Mugilan, you can see it, right?
Yes, sir.
I don't think that there is any problem from my end. Probably from due to poor network it is happening.
Okay.
Okay, so okay, so now, so we have just got P3 P1 in terms of P2. Now we have to write the entropy. Let's write entropy, that is Kb. So minus Pi, that is Pi ln Pi. In this way we will write. Let me add one page. Okay, now if you write in this way, then S becomes, let's just make Kb equal to 1 for the moment, because it will not affect our equation. That will be minus P1 ln P1 minus P2 ln P2 minus, okay, minus P3 ln P3. Now we have to write in terms of P2. So for this is 1 minus P2 by 5 times 4 ln 4 1 minus P2 by 5 minus P2 ln P2 minus P3 means 1 minus P2 by 5 ln 1 minus P2 by 5. Now the question says maximum entropy. So for a variable to be maxima, del S del P2 will be 0. That is the maxima thing, right? If one, because S because S is function of P2 only. To maximize S, we have to do the differentiation, and that differentiation will vanish, means del S del P2 will be 0. Now we will differentiate this del S del P2. It will become, for first thing, as we all know, that let's differentiate this thing. This is easy. So this will be minus ln P2, and ln x means 1 by x. So P2, this will, for ln P2 will be 1 by P2, P2 and P2 there will be 1. This will be minus 1. For this thing, for first, this will be minus 4 1 minus P2 by 5 into 5 by 4 into 1 minus P2, and now we have just used the chain rule. There is minus P2, so that will be minus 1 and 4 by 5. So it will be minus 4 by 5. Okay, so this will, this thing, and minus, now for this one only P2 will be P2 will be 1, and there is minus and minus plus. So this will be plus 4 by 5 ln 4 times 1 minus P2 by 5. Similarly for this thing, that will be minus 1 minus P2 by 5 into 5 by 1 minus P2 times minus 1 by 5. So this will cancel out. So then it will be 1 by 5, similar thing, into 1 minus P2 by 5. Now if you simplify it, let me add one more page. So if you simplify, from here it will be minus and minus plus 4 by 5, minus and minus plus 1 by 5. So 4 by 5 plus 1 by 5 will be 1. This one and this minus will cancel out. So we can write minus ln P2 plus 4 by 5 ln 4 1 minus P2 by 5 plus 1 by 5 ln 1 minus P2 by 5 minus 1 plus 4 by 5 plus 1 by 5. So this will, now if we write, then we will get minus ln P2 plus 4 by 5 we can write like 1 minus 1 by 5 ln 4 by 1 minus P2 by 5 plus 1 by 5 ln 1 minus P2 by 5. Okay, now it is 0. Now minus ln P2 plus ln 4 by 1 minus P2 by 5, and here minus 1 by 5 times ln 4 times 1 minus P2 by 5, and here 1 by 5 ln 1 minus P2 by 5. Now using logarithm we can write 1 by 5, and this minus will, let's just write. So what I'm trying to say is, this is minus 1 by 5, this is 1 by 5. So if we take common 1 by 5, then this will be 5 by 4 times 1 minus P2 into 1 minus P2 by 5, that we can write inside the logarithm. What I'm trying to mean is 1 minus P2 by 5 times 4 means 5 divided by 4 times 1 minus P2. This will cancel out and it will give you 0, means minus ln P2 plus ln 4 1 minus P2 by 5 plus 1 by 5 ln 1 by 4 equal to 0. And if you take this, then it will become ln of 4 1 minus P2 by 5 P2 equals to 1 by 5 ln 4. And if you take it, it becomes probably, let's calculate it. This is 0.277, I guess, ln of 4 times 0.277. So it becomes ln of 4 times 1 minus P2 by 5 P2, so on, 0 point equals to 0.2772. And if you do this, 4 1 minus P2 by 5 P2, it will be e to the power 0.272. Okay, so this will give you 4 minus 4P2 divided by 6.5975 P2. Let me add one more page. This is quite a bigger problem, but it will actually, so if you take this 4, this will make 10.59752. So 4 P2 plus 6.5975 P2 is 4. This makes P2 equal to 4 by 10.5975. That makes P2 equals to 4 divided by 10.5975 is 0.377. So it makes 0.377. Then what will be P3? P3 is 1 minus P2 by 5. So 1 minus answer divided by 5. So 0.125. So it becomes 0.1245. So P1 is 4 P3. So 4 times 0.498. 0.498. So we can write as 0.125. So P1 then 0.498, P2 is 0.377, P3 is 0.125. Now go back to this problem. So the first option is correct, right? Is it so did you understand it completely? Or should I go through again?
Yes,
So the
sir.
complicacy actually
Actually, I used only the first equation to find out the answers. But behind this, these many steps are there. I was not expecting.
okay. So but you didn't get the full answer, right, from here?
Yes, sir. Because of the options, I was able to get.
Ah,
If options were all same, then it would have been a problem.
yes, yes. Yeah, because also like if you add those things, that can be an educated guess, because if you see, let's just remove option A. So for option 2, P1, P2, P3 all are equally probable, so that cannot be true. That is one educated guess. Okay, for option 3, if you add them together, this is more than 1. That is also not possible. Now for the option 4, if you add them together, that is also not becoming 1. So these 3 options can be actually rejected using nominal sense, using nominal, smart ways. That is a good thing. Mugilan, you have done correctly, but you have to know the correct thing. Means, since if it is, but this is a good way. But if you have to do MCQ very promptly or very rapidly, you are given 1 minute or point like 30 seconds, then you have to do it very quickly. Then you have to just cancel some options, and you have to so option C and option D is being cancelled very quickly because of P1 plus P2 plus P3 is not becoming 1. And also like for option B can be rejected because these are not equally probable, right? So from these things, so now I will just go through once again, just for the sake of completeness, to like whenever if you given this kind of problem, how you will do it. So this thing is always right? This total probability is 1. Now average is given, means average expected profit. So we have just did the average profit, means profit with that their probability, and we will get some equations, and we have tried we have written different probabilities in terms of one probability, and we have tried to calculate the S, that is entropy, and we have written the formula for the entropy, and it is said that entropy is maximized. Now entropy is maximized. To do that, here the entropy is variable for only one variables, that is P2. So then we have to maximize it, means we have to differentiate it with respect to P2 and make it to 0. Then we have done the calculations, and after calculations we have done rigorous calculation, we got P2, and from that we get P3, P1, and that is the correct answer. Okay, so this is the correct answer. So let's just go to the next problem. Now you can do it. This you can do it. Please try. Compute the average I for the probability distribution function shown in the figure below. What you will do, the i's value is given 1, 2, 3, 4, and their probability is given. Just take the product and then take the sum. Okay, do it. Sachin, you will also try.
सर मुझे तो कुछ डिस्प्ले हो नहीं रहा है.
Okay.
So आज नेटवर्क प्रॉब्लम कुछ ज्यादा है शायद.
Okay. So you will get the notes from that list, and you will get the notes from my YouTube videos description box also. So try to follow that, but try to yeah.
YouTube मतलब YouTube चैनल वो कहाँ से मिलेगा उसका लिंक?
You are registered in this course or not? Oh, I just left it. Mugilan, try this. Mugilan, what is the answer? You can do it. You are a smart kid.
So I actually entered in formula itself. Like that one was for entropy while we were calculating for the single probabilities.
Yes.
But while calculating average, I'm not sure what the integral should I take. Like
So here,
should I have to take like 0.1 to 0.1?
Here you don't have to take the integration because it is only 1. So what you will do is take the I value and take the probability and time, just take the product. So that will be 0.1 times 1, like 0.2 times 2, and you do this way. Okay, so that integration can be written in terms of summation also, right? So this is there. Here it will be like average of I will be I times pi. Now do this.
Oh, yes, sir.
Yeah.
Thank you, sir.
Yeah.
हेलो
Hello.
सर आपको व्हाट्सएप पे प्रोवाइड कर सकते हैं?
What?
ये नोट सर आप मुझे व्हाट्सएप पे प्रोवाइड कर सकते हैं?
Notes.
Yes sir.
All notes are uploaded. All notes are being uploaded. So you in the NPTEL forum for
जी
in the, जो असाइनमेंट सॉल्विंग सेशन है ना, उसमें दिया हुआ है, देखोगे कि एक लिंक दिया हुआ है, उसमें वीडियोस का लिंक, नोट्स का लिंक सब दिया हुआ है. So what I can do, I can quickly write in the chat the link, right? That will be good. Let me just write it so that you can follow it.
Sir, I think he left.
Oh,
Now he rejoined us.
okay. Mugilan, hey, sorry, Sachin. Sachin. Mugilan, what is the answer?
Answer is 3, sir.
Yes, 3. Perfect. Yeah. So you will do it in this way. So this will be 0.1 times 1 plus 0.2 times 2 plus 0.3 times 3 plus 0.4 times 4. If you do this, 0.1 plus 0.4 plus 0.9 plus 1.6, and it is coming to be 3. Okay, so let's come to this problem. This problem says, consider a system of 4 particles having 5 quanta of energy, means total energy is 5. What is the probability to find a particle in 3 epsilon, means 3 quanta of level, for a boson, for a fermions and a classical particles? Now, since there is no time, I will try to do that and you will do this. Let's start for classical. Okay, classical means these are distinguishable. So there are 5 energy. So 5 can be written in terms of 5, 0, 0, 0, 4, 1, 0, 0, 3, 2, 0, 0, 3, 1, 1, 0, 2, 2, 1, 0, 2, 1, 1, 1. Any other thing?
No, sir.
Okay. Now since these are distinguishable, so how many ways we can write this? This will be 4. How many ways can we write this? This is 4C2 times 2, because this kind of one problem I have done in the previous session. That's why I'm trying to write it quickly. This will be also with same thing, same kind of thing, 4C2. This is like 0 choosing 0, means 1, 4, sorry, 2 same and 2 different, like the same thing. So 4C2 times 2. This is how many ways you can write it? This is 4C2, same thing, into 2, and this is just 4. And if you add them, this will be 12, this will be 12, this will be 12, this will be 12. So 48 plus 8 means 56. Question says, what is the probability to find a particle in 3 level for a 3 level? 3 level means 3 kind of 3 energy. So these 2 things are there. So if you write it, so how many possible state is there? So there are 56 arrangements. So if 56 arrangements, there are 4 balls. So total 56 times 4. Now here in this case there are 12 but in this 12 there is only there is only one particle or one ball which has 3 energy. So 12, here also like 12, but there is only one possible, that is 12. So if you took that 24 by 56 into 4 means 6, 3, 28. So this is 3 by 28. This is clear? This thing clear? Hello? Is this clear?
Yes, sir. Yes.
So what we did is there are
Yes, sir.
56 arrangements, and each arrangement there are 4 balls. So total number of, like, if we do this do this thing and if we write the total sample space, there will be 56 times 4, and in this sample space only 12 balls have three energies for this one, and for this one also like 12 balls. So 12 plus 12, 24, and we get 3 by 22. Now for boson and fermions, which are indistinguishable. So let me add one page. Okay, let me add. So we will calculate for bosons, and from that we will get back the fermions also, because for bosons any number of particles can be there in one energy level, and from that we'll get the fermions where more than 2 is not allowed. Let's write it. Okay, so okay, 0, 1, 2, 3, 4, 5. It so happen that one particle it be there, another 3 in this ground state. Let denote it by A. One particle in 4, one particle in 1, 2 particles in 0. That is B. One particle at 3, one particle at 2, other will be at 0. This is C. One particle at 3, 2 particle at 1, 2 particle at 0, 2 particle at 2, and again 2 particles at 1, and one particle at 0, and 1 particle at 2, 3 particles at 1, 1 particle at 0. So total 6 possibilities, and in that 6 possibilities total we will do the same thing. 6 possibilities, and each possibility there are 4 balls, 6 into 4, and only if we see the sample space, these two ball or these two particles will be in 3. So 2 by 6 times 4. This will be 1 by 12. Right?
Yes, sir.
Okay. Now for fermions. Now fermions, no more than 2 particles are allowed. So this will not be there. This will be there. This will be there. This will be there. This is also be there. So these two will not be there. So here total number of possibilities 4, and 2 is also here there. So B, C, D, E are possible for fermions since more than 2 particles cannot be at a single state, single energy level. Now if you do that, then it will be 2 divided by 4 times 4 divide, it will give you 1 by 8. So the option will be option number 1. Okay. Okay. Now option 2, please, Mugilan, this is theory, you can do this. Problem 2 says, in the Maxwell-Boltzmann statistics, which of the following is correct? At low temperature, lower energy states are more populated. That is possible. That is true, right? Because there is exponential e to the power minus beta e. So at low temperature, beta is higher. So the less the energy will be, the more the value will be e to the power minus beta e. Right?
Yes, sir.
So means probability of E is e to the power minus beta E. So at T decreases, beta increases. So e to the power minus beta E increases for E increases, E decreases. So this is one correct answer. Now degenerate states are equally populated. That is also true. Maxwell-Boltzmann statistics is valid
Yes,
for, hello, right? Degenerate.
yes, sir. Yes.
Yes. Now Maxwell-Boltzmann statistics is valid only for ideal gases. This is true or not?
No, sir.
No, because it can be for distinguishable particle also. Now option 4 says Maxwell-Boltzmann distribution is the most probable distribution. That is true. Sir has taught one lesson on that.
Yes, sir.
So these 3 are the correct answers. Now option 3. Now question number 3. Which of the following quantities depend on temperature? Partition function depends on temperature. True or false?
Yes.
Yes, because partition function
Yes.
z is summation over gi e to the power minus.
E power.
Yes, yes.
E power.
So there is temperature. So Boltzmann constant, no, because it's a
No,
constant.
sir.
Energy levels of the system,
No, sir.
no,
They are like given.
they are given. They are the intrinsic thing. Average energy of the system,
No, sir. That is also no.
no, that is true. This is true. Why? Because P of E is proportional to e to the power minus beta E.
Okay, sir. Okay, sir. Yes,
So
sir.
if
Then
you
we are submitting.
exactly, yes, yes. So that will be E, P of E, E. So there will be a dependence. So dependence on, okay. Now
Yes, sir.
this says certain molecule has a doubly degenerate excited state lying at 861.51 into 10 to the power minus 23 joule above the non-degenerate ground state. At 300 Kelvin, what is the percent of the molecules populating the upper state? This is easy. This is easy means we have done similar kind of problem, just few problems below. So this will be P of E is 2 times e to the power minus beta E excited minus E ground state 0. That is 2 times e to the power minus beta means here this is given 86.151 times 10 to the power minus 23. This is by 1.38, 10 to the power minus 23 times 300. What is the temperature? 300. And this is cancel out. And if you do this problem, I'm just computing it, shift E minus 861.51 divided by 1.38 times 300. It gives me 2 into 0.1248 means 0.24896. So now if you write it in the percentage, that will be 0.2496 into 100%. So that is 24.96%. So this is the correct answer, right? 25%. Okay.
Okay, sir.
Okay. Now the last problem of this session. This says consider a system of distinguishable particles having only two non-degenerate energy levels. Two non-degenerate. So there is no GI. Separated by an energy that is equal to the value of kBt at 10K. Calculate the ratio of population in two states at 10K. So this is easy. This is easy. Here temperature is also not required. Why? So P of EI and P of E0 will be, since this is non-degenerate, there will be no GI. So it will be e to the power minus EI minus E0 by kBt. Now this is given, this is kBt. So e to the power minus kBt by kBt, because it is given, right, that EI minus E0 is kBt. That is given here, kBt. So this is e to the power minus 1, and e to the power minus 1 gives you 0.37. Okay, so this is the right answer. Okay, clear?
Yes, sir. Clear, sir.
Okay. Okay, thank you. Okay,
Thank you, sir.
let me stop the recording.